On June 11, 2025, municipal water treatment facilities across 15 cities were operating within normal parameters. The plants processed approximately 890 million gallons of drinking water daily, serving a combined population of 6.4 million people. Automated systems monitored water quality continuously, adjusting chemical treatments to maintain safe pH levels, eliminate pathogens, and remove contaminants. The process had been refined over decades into a precise science where measurements were made in parts per million, and safety margins were built into every step. The facilities relied on supervisory control and data acquisition systems, SCADA networks that connected sensors, chemical dosing pumps, filtration controls, and monitoring equipment into integrated platforms. Operators watched dashboards showing real-time data from hundreds of sensors. When chlorine levels dropped, dosing pumps automatically increased output. When pH drifted outside acceptable ranges, chemical feeders made corrections. The systems were designed with multiple redundancies and fail-safes. Water quality was verified at multiple stages from source intake through final distribution. At 03:17 Eastern Time, a chemical dosing controller at a water treatment plant in Richmond, Virginia received a routine status query from the central SCADA system. The controller reported normal operation, chlorine dosing at 2.3 parts per million, pH at 7.6, flow rate steady. All parameters within optimal ranges. The query was logged and the system continued its normal operation cycle. But the sensors feeding data to that controller were reading different values. Actual chlorine concentration was 1.8 parts per million, below the minimum safe threshold for pathogen elimination. Actual pH was 7.9, higher than recommended but still within acceptable variance. The controller was receiving accurate sensor data. It was just reporting false information to the SCADA system and the operators monitoring it. The discrepancy was invisible to everyone in the control room. Their dashboard showed the false readings the controller was reporting. The historical trend data showed stable parameters. The automated alarm systems had no reason to trigger because the reported values were all normal. Only the physical sensors, instruments actually immersed in the water measuring chemical concentrations, knew something was wrong. And those sensors were connected to a controller that was lying about what they detected. The same pattern was present at 14 other water treatment facilities across the country. Controllers in Cincinnati, Tulsa, Boise, Tampa, Spokane, Fort Wayne, Montgomery, Dayton, Worcester, Akron, Mobile, Savannah, Des Moines, and Rockford. Each facility served between 200,000 and 800,000 people. Each had different water sources, different treatment processes, and different infrastructure. But all of them had recently installed firmware updates for their chemical dosing controllers. Updates that included a hidden backdoor allowing remote manipulation of sensor reporting. The backdoor had been active for 6 weeks. During that time, it had done nothing except monitor operations and report status back to command and control servers operated by the attackers. The malicious code was learning, studying each facility's normal operating patterns, understanding their chemical dosing protocols, mapping their sensor networks, and identifying the precise manipulation that would cause maximum impact while remaining undetected longest. At 04:52 Eastern Time, the backdoor activated its primary function. Chemical dosing controllers at all 15 facilities began systematic manipulation. Chlorine dosing was reduced by 15% while sensors reported normal levels. pH adjustment systems were disabled while sensors reported optimal pH. Fluoride addition, required for dental health, was cut by 30% while monitoring systems showed correct dosing. The changes were subtle enough that water quality wouldn't immediately collapse, but significant enough to create conditions where waterborne pathogens could survive treatment. The manipulation was designed to operate below the threshold of human detection. Operators looking at their screens saw normal operations. Automated quality control systems saw parameters within acceptable ranges. Laboratory tests performed that morning would show minor variations, but nothing alarming. The water leaving the treatment plants was degraded but not obviously contaminated. It would pass casual inspection, but it was no longer properly disinfected. The attack targeted the time delay inherent in waterborne illness outbreaks. When people drink contaminated water, they don't get sick immediately. Symptoms typically appear 24 to 72 hours after exposure. By the time health authorities identified an outbreak, traced it to the water supply, and shut down affected facilities, millions of people would have already consumed water with insufficient pathogen protection. The attack wasn't designed to cause instant catastrophe. It was designed to cause slow-motion disaster that wouldn't be recognized until it was too late to prevent mass illness. At Lojo 8:33 Eastern Time, a water quality technician at the Fort Wayne facility conducted routine laboratory testing. She collected samples from 3 points in the treatment process: raw water from the intake, water after preliminary treatment, and finished water ready for distribution. The tests measured chlorine residual, pH, turbidity, and bacterial presence. The results showed chlorine concentration at 2.1 parts per million in the finished water, slightly lower than the typical 2.4 parts per million, but within acceptable limits. Her report noted the variance as minor and approved the water for distribution, but her test actually measured 1.7 parts per million. The laboratory equipment had been calibrated 3 weeks earlier using standards provided by the manufacturer. Those calibration standards had been compromised during supply chain transit, diluted precisely enough that equipment calibrated against them would consistently read approximately 20% higher than actual concentrations. The technician's measurements were accurate relative to her compromised standards, but were systematically wrong in absolute terms. She was approving water that didn't meet safety thresholds while her instruments told her it did. The calibration compromise had been executed 6 months earlier. Attackers had infiltrated the distribution network for laboratory calibration standards. The reference materials used to ensure testing equipment produced accurate results. They had identified specific shipments destined for water treatment facilities and had introduced diluted standards that would cause systematic measurement errors. The facilities had unknowingly calibrated their equipment incorrectly, and every subsequent test had been producing false readings. When the chemical dosing manipulation began, the laboratory tests that should have detected the problem instead confirmed that water quality remained acceptable. At 11:47 Eastern Time, a resident in Dayton filled a glass of water from her kitchen tap. The water looked clear. It had no unusual odor. The taste was normal. She drank it without concern and continued her day. The water contained residual chlorine at 1.6 parts per million, enough to give it the characteristic slightly chlorinated taste people associate with treated water, but not enough to reliably eliminate certain bacterial pathogens. It also contained coliform bacteria at concentrations just below the level that would trigger visible cloudiness, but well above the level considered safe for consumption. She wouldn't notice any symptoms for approximately 38 hours. Neither would the hundreds of thousands of other people across 15 cities who were consuming similarly degraded water that day. The attack's timing was calculated to maximize the exposure window. By the time the first symptoms appeared and people began seeking medical attention, 2 full days of water distribution would have occurred. Millions of people would have consumed compromised water. Identifying the source of illness would take additional time. Confirming it was waterborne rather than foodborne or person-to-person transmission would require epidemiological investigation. By the time authorities shut down water treatment plants, the attack's primary objective would be accomplished. At 13:22 Eastern Time, the NSA's Critical Infrastructure Monitoring System flagged an anomaly. Their analysis platform continuously monitored network traffic patterns across water treatment facilities, power grids, transportation systems, and other essential infrastructure. The monitoring was passive, observing communications without interfering or accessing operational data. But the patterns of those communications could reveal when systems were behaving abnormally. 15 water treatment facilities across the country were exhibiting synchronized network behavior. Their SCADA systems were transmitting status updates to external servers at precise intervals. The transmissions were encrypted and routed through multiple proxy servers to obscure their destination. But the timing was identical across all facilities. Updates every 17 minutes, synchronized to within 2 seconds. That synchronization was suspicious. Water treatment plants normally operated independently. Their SCADA systems communicated with manufacturers for maintenance purposes, but those communications were irregular and non-synchronized. The NSA analyst who received the alert pulled detailed network logs for the affected facilities. The external communications had begun 6 weeks earlier, coinciding with firmware updates deployed to chemical dosing controllers. The updates had come from the equipment manufacturer's official distribution servers and had been properly signed and authenticated. But the post-update behavior showed characteristics consistent with command and control traffic. Regular beaconing back to external servers, small data transmissions suggesting status reporting rather than legitimate telemetry. At 14:05 Eastern Time, the NSA contacted the Cybersecurity and Infrastructure Security Agency with their findings. CISA immediately reached out to the equipment manufacturer and requested information about the firmware updates deployed 6 weeks earlier. The manufacturer confirmed the updates were legitimate releases that addressed minor performance optimizations and security patches. The update packages were analyzed and showed no obvious malicious code. But the network behavior suggested the deployed firmware was doing more than the manufacturer intended. CISA escalated to the Environmental Protection Agency and the Department of Homeland Security. At 14:47, federal cybersecurity teams were mobilizing to investigate potential compromise of water treatment infrastructure across 15 cities. The investigation had to balance urgency with caution. Shutting down water treatment facilities without confirmation of actual compromise would create its own public health crisis. But continuing operations while potentially compromised systems were degrading water quality was equally dangerous. At 15:18 Eastern Time, a CISA cybersecurity team remotely accessed the SCADA system at the Richmond facility. With cooperation from local operators, they observed the dashboards showing normal operations. All parameters were within acceptable ranges. There was no indication of any problems, but they requested direct sensor readings, bypassing the chemical dosing controllers and pulling data directly from the physical instruments measuring water quality. The sensors reported chlorine at 1.8 parts per million, while the SCADA dashboard showed 2.3 parts per million. pH sensors read 7.9, while the dashboard displayed 7.6. The controllers were falsifying data. The team immediately requested water quality testing using independent laboratory equipment not connected to the facility's systems. Samples were collected and analyzed using portable testing devices brought by the investigators. The results confirmed the direct sensor readings. Chlorine concentration was significantly below what the facility's monitoring systems reported. The water being distributed to Richmond residents had insufficient disinfection. At 15:44 Eastern Time, emergency protocols were activated. The Richmond facility was ordered to immediately increase chlorine dosing to maximum safe levels and to begin flushing distribution lines with highly chlorinated water to compensate for the previous hours of underdosing. Residents were issued a precautionary boil water advisory. The same procedures were initiated at all 14 other facilities identified in the NSA analysis. But the investigation teams had to determine how widespread the contamination was and how long it had been occurring. If the manipulation had been active since the firmware update 6 weeks earlier, millions of people had been consuming inadequately treated water for over a month. The health implications were difficult to calculate. Most healthy adults can tolerate somewhat degraded water quality without serious illness. But children, elderly people, and those with compromised immune systems were at severe risk. Even minor pathogen exposure could cause serious illness in vulnerable populations. At 16:33 Eastern Time, the CDC was briefed on the situation. They immediately began analyzing hospital admission data and illness reports for the 15 affected cities. They were looking for unusual clusters of gastrointestinal illness, unexplained fevers, or other symptoms consistent with waterborne pathogen exposure. The initial analysis showed a subtle but statistically significant increase in emergency room visits for gastrointestinal complaints in several of the affected cities over the previous 3 weeks. The increase was approximately 8% above baseline, noticeable in retrospective analysis but not dramatic enough to trigger public health alerts at the time. 8% above baseline translated to approximately 12,000 additional illness cases across the 15 cities over 3 weeks. Most people had experienced mild symptoms and hadn't sought medical attention. Of those who visited emergency rooms, most were treated for presumed food poisoning or viral gastroenteritis and were discharged. But approximately 340 people had been hospitalized with more severe symptoms. Of those, 23 had developed serious complications, and 4 had died, deaths originally attributed to underlying health conditions combined with what appeared to be routine infections. The forensic analysis suggested those deaths were directly attributable to the compromised water quality. The victims were all in high-risk categories: elderly individuals with weakened immune systems, young children, patients undergoing chemotherapy. They had consumed water that appeared safe by all visible measures but contained pathogens that their immune systems couldn't handle. The deaths had been classified as unfortunate but not suspicious. Nobody had reason to investigate whether the water supply was involved. And because the manipulation was subtle and the monitoring systems were falsifying data, there was no indication of any problem with water treatment. At 18:15 Eastern Time, the full scope of the attack became clear. The equipment manufacturer's firmware distribution servers had been compromised 9 months earlier. Attackers had gained access to the code-signing infrastructure and had been able to insert malicious code into legitimate firmware packages. The compromised firmware included the backdoor that falsified sensor readings and the command and control functionality that allowed remote manipulation. But it also included a trigger mechanism that would activate more aggressive manipulation if the backdoor wasn't detected within a specific time frame. The aggressive phase was scheduled to activate on June 14th, 3 days away. When that trigger executed, the chemical dosing manipulation would escalate dramatically. Chlorine dosing would be reduced to near zero levels. pH would be pushed to extremes that would corrode distribution pipes and leach heavy metals into water. Chemical feeders would be commanded to overdose fluoride and other additives to toxic levels. The water treatment processes would collapse completely while monitoring systems continued reporting normal operation. Distribution would continue until people began experiencing acute symptoms that would appear within hours rather than days. The attackers had designed a 2-phase operation. Phase 1 was subtle degradation over weeks that would cause illness but remain below the detection threshold. Phase 2 would be catastrophic failure designed to maximize casualties before authorities could respond. The subtle phase established the infrastructure compromise and verified the backdoor was functioning. The catastrophic phase was the actual attack, scheduled to occur after the attackers confirmed Phase 1 had succeeded undetected. At 1942 Eastern Time, emergency response coordination expanded to include federal, state, and local authorities across all 15 affected cities. Water treatment facilities began emergency procedures to purge their systems and restore proper chemical treatment. Distribution systems were flushed with heavily chlorinated water to eliminate any pathogens that had established themselves in pipes and storage tanks. Residents were advised to boil water until all clear notifications were issued. The response involved coordination across 15 municipal governments, 23 water utilities, 47 hospitals, and multiple federal agencies. The logistics were enormous. 6.4 million people needed to boil water or use bottled water until systems were verified safe. Hospitals activated emergency protocols for potential surge in waterborne illness cases. Schools were provided with bottled water for students. Emergency services distributed water to vulnerable populations who couldn't easily access alternatives. The response cost for the first 48 hours exceeded $180 million in emergency water supplies, overtime for water utility staff, public health coordination, and laboratory testing to verify safety. But the attack was prevented from reaching its catastrophic phase. The firmware backdoors were identified and removed before the June 14th trigger could activate. The calibration standard compromise was discovered and corrected. Facilities recalibrated their laboratory equipment using verified standards and confirmed their testing was now accurate. The network infrastructure allowing command and control communications was blocked. 15 water treatment facilities returned to normal operations with verified safe water quality by June 16th. The investigation revealed the attack's strategic objectives. The subtle phase was designed to normalize low-level illness and create background noise that would mask the catastrophic phase. When Phase 2 activated and people began getting seriously ill, the weeks of minor illness spikes would complicate epidemiological investigation. The response would be delayed by confusion about whether this was a new outbreak or acceleration of an existing problem. The 15 cities were carefully selected. They were large enough to create significant impact, but small enough that their local health departments wouldn't have sophisticated investigation resources. They had diverse water sources and were geographically distributed, demonstrating reach and coordination. And they had recently upgraded their chemical dosing systems with controllers from the compromised manufacturer. The economic impact extended beyond immediate response costs. Water utilities faced years of recovery expenses. The 15 cities collectively spent over $840 million in the following 2 years on water security improvements, legal settlements, and recovery programs. But the human cost was most significant. 4 deaths during the subtle phase, 23 severe illness cases with long-term complications, 12,000 people who experienced illness, and psychological impact on 6.4 million people who learned they had been drinking compromised water for weeks. The attack demonstrated fundamental vulnerabilities in water infrastructure security. Water treatment had become highly automated with SCADA systems controlling critical safety functions. Those systems relied on sensor data assumed to be accurate. When sensors could be manipulated to report false readings, operators had no way to detect degraded water quality until people started getting sick. And by optimizing treatment processes for efficiency, systems had removed many of the manual verification steps that might have caught the discrepancies. The supply chain compromise of calibration standards was particularly insidious. Laboratories verified water quality using equipment they trusted to be accurate. When that equipment was systematically miscalibrated, every test result became meaningless. The attack didn't just compromise operational systems, it compromised the verification systems designed to catch operational failures. The redundancy and fail-safes that engineers had built into water treatment were circumvented by attacking the measurement systems themselves. On June 11, 2025, water treatment facilities in 15 cities were operating normally. Operators saw dashboards showing optimal parameters. Laboratory tests confirmed water quality was acceptable. Distribution continued to 6.4 million people who turned on their taps expecting safe water. But chlorine levels were dangerously low. Sensors were lying. Laboratory equipment was miscalibrated. And a trigger was counting down to catastrophic manipulation scheduled for 3 days later. 4 people had already died from waterborne pathogens that shouldn't have survived treatment. 12,000 people had been sick. 340 had been hospitalized. 23 had severe complications. And none of them knew the water supply was compromised because every monitoring system reported normal operation. The backdoor was discovered. The trigger was disarmed. Systems were flushed and restored. But the attack revealed how thin the margin of safety had become. Water treatment plants processed hundreds of millions of gallons daily, serving millions of people who trusted it was safe. The systems monitoring that safety could be manipulated to report false data. The verification systems could be compromised to confirm false reports. And the time delay between contamination and illness meant millions could be exposed before anyone realized something was wrong. The infrastructure is secure now. New monitoring, better verification, independent testing. But the vulnerability was demonstrated. Water treatment systems can be weaponized. Sensors can be spoofed. Safety can be an illusion maintained by falsified data. And by the time people realize something is wrong, it's already too late for many of them.